Hi, we're team number 2, and we are going to present less foam casting and continuous casting. First off, we're going to talk a little bit about foam casting. For this process, the pattern evaporates when the molten metal is poured into the mold. The first step is the creation of the mold foam. A block of polystyrene foam is cut into the exact shape of the finished product using a hand or power tool. Second, the mold then is dipped into the sheetrock, mud, or plastered, and then coated Third, after the foam is finished, it's buried in a container. Then the very ends of the foam shape are left to expose to facilitate the entry of the molten metal into the mold. Fourth, when the metal is poured, the cylinder walls contain it and it's allowed to build up in the piece, creating more pressure and therefore a more thorough casting.
In the history of the process, we have first in 1956 that the first patent for an evaporative pattern casting was built in April by H.F. Schroyer. He patented the use of foam patterns embedded in traditional green sand for metal casting. In his patent, a pattern was machined from a block of expanded polystyrene and supported by bonded sand during pouring. This process is now known as the full mold process. In 1964, M.C. Fleming used unbonded sand for the process. The first North American foundry to use evaporative pattern casting was the Robinson Foundry at Alexander City, Alabama. In 1981, the full mold process was referred as lost foam casting, but later the two processes were clearly differentiated by the use of unbonded dry silica in lost foam casting, while bonded sand was used in full mold process. This process gained world famous when General Motors first implemented it to manufacture 4.3-liter V6 diesel cylinder head in 1981. And finally, in 1997, a study found that the evaporative pattern casting processes accounted for approximately 140,000 tons of aluminum casting in the United States, and the same survey forecast that evaporative pattern casting processes would account for 29% of aluminum and 14% of the ferrous casting markets in the near future.
Type of mold and pattern used and materials that it's used. Firstly, a pattern is made from a mold using a variety of methods. For small volumes, bronze pattern can be cut by hand, machined from a solid block of foam. If the designs are simple enough, it can be even cut using a hot wire or a foam cutter. Though, if the volume is really large, the pattern can be mass-produced by a process similar to injection molding. A pre-expanded bead of polystyrene are injected or blown into the preheated aluminum mold at a low pressure, injecting steam into the tooling cavity that expands the beads. The final pattern is approximately 97.5% air and 2.5% polystyrene. This mold is expendable due to the evaporation of the material. Types of metals that can be casted. Lost foam casting is used mostly for automotive applications. Cast iron, aluminum alloys, steels, nickel, and in some cases stainless steel and copper alloys are cast into this process.
The types of parts that can be casted has a lot of flexibility, is useful in making complicated casting assemblies for automotive parts like cylinder heads, weldments, sculptural pieces, circuit boards, etc. The size range is from 0.5 kilograms to several tons. The minimum wall thickness is 2.5 millimeters and there is no upper limit. Typical surface finishes are from 2.5 to 25 micrometers, and the typical lineal tolerances are plus minus 0.005 millimeters or inches.
Well, this process has a lot of advantages. The first ones are that it's really simple and can be used at home foundries. Also, the cleaning cost is reduced due to the lack of sand. This process also eliminates the need for sand binders and cores. The tooling in this process does not wear away easily. Also, complex shapes can be cast near net shapes. Simple and inexpensive method for casting complex constructions. Castings require minimal machining. Castings are dimensionally accurate with excellent surface finish. On the downside, we can see that the cost of the pattern can be high for low production volumes, and it can be easily damaged or distorted due to the low strength. While when a die is used to create the patterns, the initial cost of the die can be quite high.
The machinery we found that can be needed for these processes, we divided into 3 websites. We found first in Qingdao KG, then Vulcan Group, and then Antai. These 3 websites are from China, and in the 3 we can see that they sell all the production line to make this lost foam casting, from the machines produce mold, the machines that fill it with sand, and the machines that pour the molten metal into the mold. Here we can see also the 3 websites.
An example of the application, like we saw in the history process, we saw that GM had a really popular way of making some of the engine blocks. This is an example of the Saturn series of 1981, which a lot of the pieces were made out of this process, especially the engine block.
So now we are gonna present a short video of the lost foam casting process.
The lost foam casting process can produce dimensionally accurate castings with excellent as-cast surface finish. Larger parts in low quantity can be made with EPS foam blocks. The EPS blocks are machined to the shape of the final product, with metal shrinkage accounted for. Smaller parts in high quantity can also be made using molded EPS made by steam injection. The machined EPS parts are then covered in a hardening coat. Next, the painted EPS part is placed in a mold. The feed sprue and upriser are added to the EPS part. Then the mold is filled with casting sand and compressed. Molten metal is poured through the feed, and the hot metal burns away all the EPS foam, leaving a metal part of the same shape. The casting is then cooled and removed from the sand mold. The casting part is first cleaned to remove any remaining surface paint and sand. Then the feed and upriser components are removed to produce the finished casting part. Thank you for watching. Check out other casting processes on our channel.
Well, now we're going to talk about the continuous casting, which is a different process. First, we're going to describe it a little bit. This continuous casting process is also called a strand casting. And it is a process where a metal is heated until it liquefies, and then the molten metal is solidified until it becomes a semi-finished slab. And then it is rolled in the finishing mill, and then it's done. Something remarkable about this process is that all the steps that are shown in casting, these occur simultaneously. This means at the same time, which makes it faster. Here are the steps that you need to follow in order to make this continuous casting. First, the metal is liquefied and poured into the mold. but the impurities and slag are filtered. The entrance of the mold is filled with inert gases to prevent reaction of the molten steel with the gases from the environment. The molten metal moves swiftly through the mold and without completely solidifying. The entire mold is cooled with water flow, and then the metal casting moves outside the mold with some rollers.
In the history of the process, we can see that it all started in the early 1843, where the idea of casting process to make the casting process more productive, effective, and fluent were attributed to G. Lang, who in 1943 patented and tested a machine for horizontal continuous casting of tubes and sheets from low melting metallic alloys. In this invention, Lang proposed feeding the liquid metal from a vertical reservoir to a preheated horizontal mold with an inserted mandrel that rotated around its axis to prevent sticking to the casting. Further development of continuous casting is ascribed to Henry Bessemer, who in 1857 suggested and patented in the UK a device known as trim-roll caster. It took more than 100 years for the continuous casting of steel to become a mass production technology. As we can see in the timeline, it all started in 1943 and it ended at 1950, where it already became a continuous casting mass production technology.
Well, the mold and pattern used in continuous casting is basically a permanent open-ended box structure, and it contains a water-cooled inner lining. Usually it is fabricated with copper alloy, but sometimes they add other alloying elements to increase the strength. Usually it is chromium or nickel. The depth can range from 0.5 meters to 2 meters, depending on the casting speed and the section size. And in the image below, we can see some examples of the patterns that are used. They usually have some shapes like rectangular, hexagonal, or cylindrical.
The types of metal can be cast. As we can see, we can cast a lot of metals in this process, like cast steel, copper, aluminum, gray cast iron, white cast irons, oxygen-free copper, aluminum bronzes, and some others. But the main three that are usually used to this process are cast steel, copper, and aluminum to create some different products, as we're going to see later in this presentation, the applications.
The type of parts that can be casted this process is mostly used for tubes and solids with, like I said before, cylindrical, square, rectangular, hexagonal, or many other irregular shapes. And something remarkable is that it is also used for gears with teeth. The standard length for this process is 144 inches, but the width is way lower than that.
Now, in the advantages of this process, we can see that all the steps occur congruently, and hence it saves a lot of processing time. Helps to lower the cost of cast steel, helps in the standardized production of cast steel cast, reduces errors leading to better quality steel casts. They eliminate pipping, structural and chemical variations, and possess uniform properties. As we can see in the process, all in the image, it all happens continuously and congruently, which refers to the first point, and that's a great advantage. Now, continuing to the limitations, we have that just can be cast as simple shape, as we can see in the image. It's just tubes or rectangular shapes, not recommended for small scale production. Recommended, sorry, because as we can see, it is a great. Well, it's a long process, and it wouldn't be recommended for casting small scale production because uh, it will cost a lot, require a lot of space in terms of area inside of the industry. The process takes a lot of investments, as I said. The impurities and slag are filtered before they move into the mold. The molted metal moves swiftly through the mold and does not completely solidify in it. Those are some limitations, and we're going to proceed to machine needed for this process.
When we were doing our research, we found some companies that offer the machinery for this process. One of them is Bowling Machinery, and as you can see in this image, these are the different machines that you need in order to do our process. But they offer different types of these machines. For example, for the rolling mill, they offer a hot rolling. Well, inside the hot rolling mill, they offer a bar mill, wire rod rolling mill, section steel rolling mill, and well, also unit equipment and parts. There is also another company that offers these machines, and it is Shanghani Tech Company. This is a list of everything they offer. As you can see, is similar to the one before. Mostly they offer different types of rolling mills, and here is the list of all they need. And these are some examples of the way they look when they are assembled.
And now the application. We can see that this metal is used to produce different shapes like pipes, whites, rods, and plates of metal. And it is usually used for high volume production, as I already mentioned before. As we can see, the different shapes that continuous casting produces are rolls like copper rolls, or plates like steel casting plates, or some copper tubes or pipes, as we mentioned before in the materials and application. Now we're going to see a video that we found on YouTube that explain the process.
Continuous casting is the process used to solidify the molten steel ready for shaping into a huge range of final products. A ladle of steel is teamed or poured through a gas-tight refractory tube into a tundish. The tundish is a reservoir that allows the steel to flow at a controlled rate through further gas-tight refractory tubes and into a series of water-cooled copper molds. With only the outer shell solidified, the steel is drawn from the bottom of the mold through a curved arrangement of support rolls and water sprays. It emerges horizontally in the form of a solid steel strand. At this point, it is cut to length using automatic gas burners. Depending on their size, these solid shapes are called billets, blooms, or slabs, and are now ready for shaping into finished products.
Well, this would be everything. We hope you understand these different processes. Thank you.